this was the warm-up. Okay, can you find this? We're just going to officially write this equation down. You've done like 2 or 3 practice problems with it already. Percent dissociation is the same thing as percent ionization. Dissociation is just the word for the water dipoles separating. Ionization is just like a synonym. It just means turning into ions, which came from the water dipole separating. It's always, no matter if you're just doing like a regular equilibrium problem or a KSP problem, anything, it's always going to be whatever X is divided by whatever the initial starting concentration was. Okay, that's all I wanted to say about that. You want to get out the white sheet next. We're going to learn on the white sheet. Okay, we have one more column to do in that white sheet, our salts. And I have some brain animals for you. Okay, so today we are going to be learning how to find the pH of the green beaker. If I take an acid, so this is acetic acid, not that you need to know the name, but it's a COOP, right? So it's a weak acid. And I react it with sodium hydroxide. It's in the boot, so it's a strong base. Anytime I take any acid in any base, it's just like what I picked for an example. Any acid, which my brain eyeballs I saw is yellow, any base in my brain eyeballs that I saw is blue, will make what's called a salt. A salt is just any cation and any anion. The cation is the positive, the anion is a negative. And so yellow and blue make green. Today now, we're going to be given the green, have to think backward to figure out what the blue was and what the yellow was so we can solve for the pH, okay? The problem is, the challenge is these greens have lots of letters to them, okay? And on that KSP quiz, I gave you oxalate, which is like a new thing, and some people are like, oh, it's oxalate. They're just letters. If you need to look them up, look them up. These are all going to be somewhere on dinosaur or dinosaur point 2. If I look here at my strong base, NaOH is just, that's where the Na comes from. That one's pretty easy, but if you take from those weak bases, those NHs and Cs and Hs, and if you get a big coup, these salts can have lots of letters to them, and they're like, oh God. But you just have to figure out where they came from. What is the blue? What is the yellow? Okay? I changed my mind on cation and anion. So if you wrote in pencil, which probably didn't, but maybe if you did, can you erase it if you didn't? We're going to change it to base and acid. So the salt is going to have part of a base, part of an acid. If the base part is strong, so like this one, the blue base part was a strong base. I know that because I have practiced memorizing my strong bases. Then our first step is we are going to solve for Kb. This is a secret equation we haven't really used yet. Kw equals Ka times Kb. Kw is at 1.0 times in the negative 14th number. We're going to solve for Kb. Once we have Kb, then we're just going to do our regular ice equation. We know how to solve for x because we've done our homework and practiced that. When we solve for x of a base, though, x does not equal hydrogen. What does it equal? Tell somebody next to you. Or not. right? And so we have to do POH first. Oh, God. Very good job. But then we can get to pH, right? POH plus pH equals 14. I'm going to just switch to red just because clearly I did a really good job with my space, just so you can tell what's different about it. If the acid from the salt, so if the yellow is a strong acid, this one's not, this one's weak, but if the acid was strong, we're going to solve for Ka. Using our new secret equation, Kw equals Ka times Kb. Once we have Ka, we can do our x's, just like we've practiced a gazillion times. Once we have our x's for an acid, x equals the H3O plus, so then we can just do our pH equation. Okay. So keep that next to you. Let's do the sample problems, which are going to be like page it, page it, page it. Here it is. Before we start, though, you need to tell somebody the 7 strong acids and the 8 strong bases, but don't look at my note. Ready? Go. Thank you. Okay. So, biggest battle is that first step. We need to go from this green salt back to the blue and yellow so we know what to do, how to do our math. If we're going to do blue math, if we're going to do yellow math, okay? So lots of letters. What we're doing, oh, it's right there. What we're doing is we're figuring out whether it's going to be acidic or basic. Good morning. I like blueberry.
Come on. Happy Friday.
Happy Friday. Thank you. No, I'm good. Okay. What are you going to tell me?
I top of sky. I toast do it too.
You got it. Have a good weekend.
Wait.
Bye. Thank you. Okay. She's like, no way. What did you forget? Oh, your phone. Bye. Have a good weekend. Okay. I like to do it like this. So I like to split it back into its blue and its yellow just by a dash. Now, I don't know what the name of this is, and the name doesn't matter, but I can look at that and be like, that definitely was a weak acid, right? It's going to be some kind of Q. It just lost its hydrogen. Now, for barium, barium is in my hydroxide boot. My hydroxide boot is going to be a strong base. So what that means is that this salt is basic. And that means I need to solve for Kb, B for base. Okay? So now with your battle buddy, see if you can find the blues and the yellows for the rest of those. Ready, set, go. Letter D is a trick question, and it does come up if it's strong, because potassium's in the boot, so I know that's going to be strong base. I'm learning my letters of my strong acids. HNO3 is nitric acid, is a strong acid. So if it asks you to solve for the pH of this, trick question, it's 7. It has to be neutral because they're both strong. No matter what, If my blue and my yellow are going to be strong, my green is automatically pH of 7, it's neutral. It doesn't matter what these are. The pH, if I took it, this would be 7. Okay? Let's do some math and actually solve it all the way through. That's not right there. Calculate the pH of a 1.10 molar NH4Cl solution. Step 1 is looking at this and figuring out what category it goes into. We've learned 6 different ways to do these problems. So I would, just to start and get used to it, start on the left. Is it a strong acid? NH4Cl, no, it's not one of the 7 strong acids. Okay, is it a weak acid? It is not an H something or a Cu, so it is not a weak acid. Is it in the hydroxide group? No. Is it a weak base? Now, this is where I might get stuck because it does have that NH thing on it. But all of those dinosaur 0.2s have an NH with like a C. They don't have a chlorine on them. So I know that it's not going to be a weak base, and if I'm not sure, I'm looking it up on dinosaur 0.2. Like you have dinosaur 0.2 for the test and everything right now. I'm double checking to make sure this isn't there. And so then I can eliminate that, so then I know it's a salt. Once I'm in the salt category, my next step is to do this. I know HCl, because I've practiced my strong acids, is going to be a strong acid. My NH4 is not a strong base. NH3 is a weak base. Does it really matter if you know the names? No. Not at all. There's a huge list of that dinosaur. All those Cus have weird names. It doesn't really matter. It's just that you can recognize that it's a weak base. So that means that this is going to be acidic. And I need to solve for Ka, A for acid. And that's the first thing I'm going to do. Kw equals Ka times Kb. Kw is a constant, Ka is what I'm solving for, and I need to get a Kb off a dinosaur 0.2. So can you pull out your gold packet, look at dinosaur 0.2. What am I looking for on dinosaur 0.2? Yeah, we got to get the number, but there's a bunch of different options. How do I know which one to look for? Which one does this match? Yep. NH3, is that it? I literally just made that up. So the one that matches it is NH3, which is, I think, the very first one on dinosaur 0.2. Okay. So go ahead, push your buttons. It's not about pushing buttons, it's about being active in your learning. And get your Ka. And now I can do my Ka math. And my Ka math, is that right? Okay. My Ka math is just like, I take my Ka equal to x times x over my initial, which is 1.1 minus x. Remember, negative times so teensy. I can eliminate that bottom x, so I'm just going to multiply it and square root it. It's an acid, so I can go ahead and get my pH negative log. Okay? So I'm going to have you start working on your worksheet with your bad buddy and with me here. I don't really want you to try to do these without me here to start. So it starts on number 17, I think. Yeah. Start at number 17 and you are going to stop at 21. So 17 to 21.